Hello friends, in this problem I'd like to show my solution to the following problem from the Estonian Mathematical Olympiad 12th grade final round 1997, problem number 2. So we are given that a function f satisfies the following condition for each positive integer n. F of 1 plus f of 2 plus and so on plus f of n equals n squared times f of n. And we also know that f of 1 equals 199. We wish to find f of 1997. So my hint for this problem, so denoting our equation by asterisk, write a similar equation but for n minus 1 instead of n. And that might lead to finding a simpler recurrence for f. And then you can try to solve this recurrence by telescoping. So give it a try and see you in a moment. Okay, so I hope that you tried something. And first of all, let's write our equation. Let's write our equation. And let's notice that it should hold for every n. So instead of n, it should also be true going up to n minus 1. So we will have n minus 1 squared f of 1 minus n. And now our equation will become much simpler if we subtract these two equations, because we get f of n equals n squared f of n minus n minus 1 squared f of n minus 1. Perfect. And now let's put f of n on one side, f of n minus 1 on the other side. And after a bit of factorization, we get this. And now this square cancels with n minus 1. After division, we get that n minus 1 over n plus 1 times f of n minus 1 equals f of n. And this holds for every integer greater than or equal to. Okay, so it's a much simpler recurrence. And now we will expand it a bunch of times and we will see a pattern emerging. So f of n equals n minus 1 over n plus 1 times f of n minus 1. Writing it again, it's n minus 1 over n plus 1 times n minus 2 over n times f of n minus 2. Again, n minus 1, n plus 1, n minus 2 over n minus 3 over n minus 1. And let's write it once more. Let's write it once more. Okay. And we see probably, I hope so, that we see a pattern. After doing it a bunch of times, we will get the following. n minus 1 times n plus 1 times n minus 2 over n times n minus 3 over n minus 1 times n minus 4 over n minus 2, and so on and so on. And the end, let's see, in the end we will get f of 1, and there will be 1/3, 2 over 4, 3 over 5, 4 over 6, and so on. And now we can see that a bunch of terms will telescope, because let's see, here we have n minus 1 in the numerator, here we have it in the denominator, here we have n minus 2, and as well n minus 3 will cancel with one fraction inside this ellipsis, and so on. And on the other side, we will have 4 and 4, 3 and 3, and also this 6 and this 5 will cancel with previous terms. And we get 2 over n times n plus 1 times f of 1. And recall that f of 1 is given in our problem, it's 999. Okay, so we have an explicit formula. We have an explicit formula for f of n. So for every n greater than or equal 1, f of n equals 1998 over n times n plus 1. Well, we showed that for n greater than or equal 2, but for n equals 1, this equality also holds. It's easy to verify it. And now we want just to plug in. For n equals 1997, we get f of 1997 is 1998 over 1997 times 1998, and after last simplification we get our answer. Our answer is f of 1997 is 1 over 1997. And that closes our problem. So thank you for watching, hope that you learned something, and see you next time. Bye.